The derivatives of trigonometric functions. Alright, so here they are, the derivatives of the trigonometric functions. So remember there are 6 trigonometric functions, and the derivatives of each are provided below. So the derivative with respect to x of sine x is cosine x. So the derivative of sine is cosine. The derivative of cosine x is negative sine x. And now we can get into the derivative of secant x. So the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant x, which can be written as secant squared x. And then the derivative of cosecant x is negative cosecant x cotangent x, and the derivative of cotangent x is negative cosecant x, which can be written as negative cosecant squared x. So you might be thinking, how am I going to remember these? So I'm going to try to give you some tips and tricks to help you remember them, but ultimately you just kind of have to memorize them. So, the ones that I can't necessarily help you with are that the derivative of sine is cosine and the derivative of cosine is minus sine. But some tricks for all the derivatives that start with co. So the derivative of cosine, cosecant, and cotangent are all negative. So there's one way to help you remember part of the derivatives. So if it's a derivative of a trig function that starts with co, it's going to be a negative. Now, the derivative of secant x, notice, is secant x tangent x. So what's involved here is that there's 2 copies of secant x and 1 copy of tangent x. Now, the derivative of tangent x is secant x. So there are again involved 2 copies of secant x with 1 copy of tangent x. So that's one little trick that I've seen students use, is to help them remember that when it comes to tangent and secant, that there are always 2 copies of secant and 1 copy of tangent involved. So the derivative of tangent is secant squared x, so secant x. The derivative of secant x is secant x tangent x. And then the same little rule applies to cosecant. So the derivative of cosecant, so there's a cosecant and a cosecant, and then 1 cotangent. And then for the derivative of cotangent, there's the 1 cotangent and 2 cosecants, which combines to be cosecant squared. So they're little tips and tricks for helping remember them, but ultimately you really do just have to memorize them. So the derivative of sine is cosine, the derivative of cosine is minus sine, and again the tricks are the derivative of any trig function that starts with co is negative, and then derivatives involving secant and tangent have to have 2 secants and 1 tangent, and derivatives that involve cosecant and cotangent have to have 2 cosecants and 1 cotangent. Alright, so the next thing I want to show you, just in case, although it's definitely not time efficient, is what happens if you forget the derivative, let's say, of tangent x. Well, if you remember a little something about trig, like your trig identities and the quotient rule, we can kind of wiggle our way through and get the derivative of tangent x without having to memorize it. So tangent x is sine x over cosine x. So that's the quotient identity for tangent x. Now that we have tangent written as a quotient, I can apply the quotient rule, which says low d high, so cosine x times the derivative of sine x. So you still have to know the derivative of cosine x and the derivative of sine x. So cosine x times cosine x minus, so we have low d high minus high d low. So the derivative of cosine x is negative sine x. So that would make this positive, and we have sine x all over low squared. So cosine x is a quantity squared. So the numerator is now cosine squared x plus sine squared x all over cosine squared x. So hopefully something is screaming out to you to simplify, which is the numerator. Cosine squared x plus sine squared x is a Pythagorean identity. It equals 1 over cosine squared x. And now this is a reciprocal identity. 1 over cosine is secant. So since there's 2 copies, it's secant squared x. So the derivative of tangent x is secant squared x. And you can imagine the same is going to apply if we rewrite cotangent x as cosine x over sine x and apply the quotient rule. And now here are some reminders regarding the trigonometric functions. The first is to always, always, always stay in radian mode on your calculator. The next is that sine squared x is really the function sine x as a quantity squared. The next, even though we haven't gotten there yet, we are going to talk about inverse trig functions, which have their own sets of derivatives. What I want you to know right now is that arc sine x is the same as sine inverse of x. But this little -1 doesn't work the same way it does when it's attached to just an x. So in other words, you cannot just take sine x and move it to the bottom of a fraction because you see a -1. That does not work. It's not the same thing. This -1 means inverse. It doesn't mean that sine x is being raised to -1 as though it was a number. It's more of a terminology. The next thing is this is called the double angle identity. So sine 2x is 2 sine x cosine x. But more importantly, here's what sine 2x is not. Sine 2x is not 2 sine x. So in other words, you cannot just take this 2 and bring it to the front. That does not work. So these are does not equal signs right here. And same thing on the next one. So similarly, sine 3x is not 3 sine x. You can't just pull out the 3. It doesn't work like that. And just in case you were thinking that it does work like that, let's go ahead and try it. So if it did work, if sine 2x was really the same as 2 sine x, I should be able to plug in something for x on both sides and get something equivalent. So we already know this isn't true. It's not going to work out. But let's go ahead and try to plug in. How about pi over 2? So then sine of 2 times pi over 2. Well, the 2's would cancel, so it's like taking sine of pi. And sine of pi, so sine is the y value. So let's just kind of draw the unit circle real quick. Pi is over here. This is the coordinate point -1, 0. So sine of pi is 0. So now on the right side, we would be doing 2 sine of, plugging in pi over 2 again. So we'd have 2 sine of pi over 2. Pi over 2 is up here. Whoops, that's a 2. This coordinate point is 0, 1. So the y value is 1. So this is 2 times 1. So does 0 equal 2? No. So if you ever think a property works, try it out with numbers. But the warning is don't try it out with the number 0 because that's going to make you think it works for everything. And 0 is a special number, or even 1 for that matter. So you have to try something else. So this does not work, just so you know. And this double angle identity is pretty useful to know. Although it hasn't showed up on the AP test for a couple of years, it has appeared sporadically, so it is an important trig identity to know.